So, I was sitting at home, and then I got this. So for the guys behind you, this is actually 1,300 something quid. Yeah, I was scared. And I wanted to find out what's our power consumption. So I did what every engineer would do, get the most cheap energy reader and try to measure where, in what power outlet your power consumption is that high. So, but that did not work out, of course, because we have lots of power outlets. My girlfriend uses power, I don't know for what, when I'm not at home. So this did not work out, and I was rather confused after that. So I could not call Confuse a Cat, because I was already. So I'm Karl, this is my Twitter handle. Of course we are hiring, as everyone does, at Lucini.de. We do Node.js projects. So, when you get, in the first time you think about power measurement, it's rather easy because you think, yeah, power equals voltage times the current flowing through. And of course, this is true if you run from battery at home, which you don't do. And when you run from a power outlet, it gets way more complicated because it looks somehow like that. Depending on the load you put on the power outlet, be inductive, capacitive, or resistive. So, I found a good explanation. I found a good explanation for how the power behaves. This is more fun, actually, German, but so actually you have the real power. This is what you later pay. You have an apparent power, which is the power combines the power you actually use and the power that's induced by using inductive or capacitive devices. And yeah, as I said, you can look it up. It's the power triangle on Wikipedia if you're more interested in it. I'll provide some links at the last slide. And you pay actually that. So it's even more complicated to measure exactly only that portion because you need to, see what you actually use and what you actually pay, because it would be different if you do it in any other way. So there are several ways to measure it. I promised to show you 3. I promised to show you some engineers porn as well. The first way is this guy, you already know, and it's called the Ferraris counter because of the guy who invented it. And it's rather old design and it's ugly like the cars here. And as I promised some porn, here's the guy again, and here's the guy without the... And inside the guy, there is some coils where the current is running through and inducing eddy currents into the aluminum disc that rotates and has that nice red mark. So a lot of interesting guys at Volkszähler or Energy Meter, there are several projects in that area, found some way to use a reflective optocoupler to detect whenever the red mark passes the counter. And actually I've seen that at the neighbor's place. And the measure when the count comes in, and on the actual energy counter it says 150 rotations per kilowatt hour. So you can then calculate it and then find it. And you need some rather, it's trivial, but it's rather hard. You need an optocoupler which collects the red mark, and you need a Schmidt trigger or something like that, some comparator to remove the noise and only detect it once. And then you have some nice spikes you can count on your Raspberry Pi, for instance. The second method is, if you're more sophisticated, you measure the actual current flowing through the wires with a transformer that looks like that. The downside is it's rather noisy, so you need some filtering solution to get the spikes again, which is, it's no fun, but it works actually. There are implementations on Volkszähler.org or on the Energy Meter projects you will find in the links. If you are more advanced, you could use a Hall effect-based current sensor. You push it over the wire, and it has there are even models available that actually filter all the stuff and push out nice spikes you can count. But if you're a good engineer, which is a lazy engineer, I forgot. It's still rather complicated because you have just the core power, and then you need to integrate over the sinus wave of the alternating current to actually calculate the the real power you will pay for. And this is a cool implementation which is okay on a DSP but not on an Arduino, which uses FFT to calculate the real power and all the power parts out of the measurement of the sensor over time. So the next problem is space, because when you use the transformers in a typical flat in Munich, the cables are like on that space, and we will not be able to fit even the tiniest power transformers over the cables. So I looked that up, it's Nick Park's first work. So we are lazy engineers, use this guy here, which is a model that's no longer produced, so it's rather cheap on eBay, which is a MID calibrated energy counter. You can actually use it to bill your neighbors with your power consumption because it's calibrated. And what it does, what the red mark says, it puts out some number of impulses per kilowatt hour in some nice digital way. So what you do is you bargain on eBay for, in my case, like 57 euros. You bargain the counter, and then you have, and really do it, get a professional electrician to install the device, because when your flat burns, the insurance will pay, otherwise it will not pay. This is how it looks when it's built in, very unspectacular. And as it has that so-called S0 interface, which is some fancy European norm, it has a potential free output with an optocoupler, and it simply closes that transistor. Think of it like a switch, it closes it 1,000 times per kilowatt hour. So the more power you consume, the faster the switch will go, and then you have to couple it to the microcontroller or the Raspberry Pi. And, as this is a lightning talk, be warned that a Raspberry Pi GPIO port takes 3.3 volts and no more. Otherwise, it will actually explode. This is...
You tried that, didn't you?
Yeah, several times. I think there are, from the 18 GPIOs, there are 4 left that work. So this is why, if you're a good electronics engineer, you use something like that. This is an optocoupler, which has a Schmidt trigger built in. There are several available, and if you have a PC, you can rip it out of the power supply of the PC. It will contain one. And the Schmidt trigger has a hysteresis, and it will remove the noise of the wire you run from the counter to your Raspberry Pi, depending on how it looks at your place. This is how it looks when it's actually soldered on a PCB and pushed onto the Raspberry Pi. The wire runs straight out from the blue counter. And then there is a cool piece of software called on-off that uses the wire.wirepi, I think is the core module. It's a kernel module and a user space library that captures the GPIOs and makes it nicely usable. And someone has written a nice Node.js module where you can just require the on-off, and in the second line you can configure any of the GPIO and say it's an input and output, can say it's a rising edge trigger, falling edge trigger, or level trigger. And then you have in line 8, the S0 port.watch is the callback that's called when the interrupt occurs. And then you simply count. And this is very easy when you come like me from embedded programming, because nothing runs, there is no actual interrupt because there is no parallelism in Node.js. Everything runs in one thread, so you don't have to take care about locking or anything. And then you have a method, a function, sorry, for JavaScript, it's function. You call the function periodically and collect all the ticks that have been counted by the counter. Actually, what took me most is the simple calculation to calculate the 1,000 ticks per kilowatt hour to the ticks collected over other time. And of course, probably the CSS only spinner I did. And then, as you see in the console log, it will show you every 60 seconds or whatever the sample time is, which show you how much power you have consumed. Now, you need to file that somehow so that you can later on use it and see how much power did you consume on Sunday where you have not been at home, for instance. So there's Cube to the rescue, the nice payment company that produced that thing that you push on your iPhone and you can charge a credit card with. They had some reporting issues, I guess, because they did a very nice library based on MongoDB. where you can store and query and run metrics on time series that you push with a HTTP or WebSocket interface into Cube. So you can store events, just do a post on the port that's open, and it's the cool thing is it's completely arbitrary. What you put in data is any arbitrary JSON object you might think about it, and you can then query even with object comprehension into that thing later on. And the second thing is when you provide an ID, I'm using the time again, you can even update the thing. And what you can then do is do metrics queries against all the data you collected. So I can do sum, a min, max, median, distinct about anything I stored earlier, like the ticks up there. And then I can say I want to consolidate it, like you probably know RRD, the RRD graph tool. You can consolidate it on the fly to a certain amount of time you want to say. For instance, the 5-minute average. Be aware that this is not arbitrary like the documentation suggests. It took me several hours to find that out. And what you also can do is use some filter expressions. You can say you want only the ticks greater than 10 per unit you select or less than something like that. You can even use regular expressions, I guess. This is a really powerful thing. Now, that Cube uses MongoDB, so you need to get MongoDB on your Raspberry Pi, because I wanted to run it on Raspberry Pi, which is not so easy because actually it does not work. Because the Raspberry Pi is a big Endian architecture with the ARM CPU. However, if you compile it and you don't care about compatibility of the data stored with an Intel box, it somehow works, and some guys actually did a port of an older version. I think it's 2.1 or 2.2. These are the two versions that are there. The marked one with the arrow MongoPy, this is what I used, and I suggest cross-compiling, because it takes 9 hours on the Raspberry Pi and it gets rather hot. So, what we have to this point, we have some GPIO from the counter, causes interrupts, nice interrupts, we sample them over the time and we store them nicely. But then we are engineers and we need to somehow display it nicely. And I can recommend about, after a whole weekend of research, to use Float, which is a really nice JavaScript library, including live updates where you can plot almost anything over a time, and it looks very nice and it's highly customizable, and there are lots of plugins for it.
It works in IE6.
Hmm?
It said it works in IE6.
Yeah, right.
Awesome.
Awesome. Okay. Here's a small demo. This is how it looks. It loads afresh. And I don't have enough time, but actually my girlfriend is on call, so she could put on her hairdryer and everything, that we can see that it updates live. Yeah, we can do that. Yeah. So this is my actual Raspberry Pi, and yeah, what's very interesting is that compared to RRD graph or most other time series databases, it does not consolidate the data and drops the actual counts. But you can any later point in time, you can select, you can change the averaging. Like you can say, I want the 5-minute average, and then you can see that it averages for 5 minutes or for an hour, for something like that. You see that the scale also fetches. What I also did is, so I want to see what happened between 8 o'clock and 18 when I was not at home, and even had entered the money it costs per kilowatt hour, so I can see it costs 1.60. And as I started to work with it, I added weather, so that I could see something in the graph before the actual counter has been installed by the electrician. So this is actually an easy way to, okay, not so easy because you have to install the counter and everything, but from the software side, it's rather easy to collect all the data. There is almost everything already available in the Node.js universe. There's the interrupt handling, the time series database. In the JavaScript framework, in the JavaScript world, there is the Float library. There are boilerplates with Bootstrap, and this can actually, if you write down the IP address, you can log in with your Facebook or Twitter or GitHub account because that's all already there in the Node.js universe. This is what makes it really fun to program something with it, and then you use Bootstrap, and you have. So you can see the red mark is starting. My girlfriend is consuming 5 kilowatts per hour at the moment. I will still marry her in February. But you can see, and this is the cool thing, this is why I selected Float in the first place, because you can easily do live updates of all the data. So yeah, this is the thing I made, and yeah, what's planned is this here. This is my GitHub. It's been a private repository because my guys here are code police and my code is very ugly, but still, if someone is interested, yeah, right, because I don't write tests. But if you're interested, I'm releasing the repository now, so you can have a look, if I remember my password. No, 00000, as it has been in the Minuteman missiles for years. So hopefully the first live code release on the MNUG. Have a look at it and play with it and give feedback. Thanks a lot.